And well, there are a couple different embedded system examples. I can go over these quickly. I mean, these are not necessarily for your project, but just to give you some example, right? Okay. So sprinkler controller. I don't know if people here know much, but if you live in a dry country or dry area like California, which I did for a long time, then you know about sprinklers. Because it's all dry, so you have to rely on sprinklers to water the landscape to get the green grass and all that. Now, sprinklers are automatically controlled. So there's usually a timer in there, and you set the day of the week and the watering time, the time zone. And then what happens is, okay, when time comes and it's enabled, then it generates an electrical signal to the valve there. Valve is electrically controlled. So usually that's a little electric magnet that allows you to turn on and off that faucet effectively, right? And then when water is running, then it sprays water, sometimes with a little thing to kind of bang on it. Okay, so that's kind of the overall. And then this thing's been around for a long time. I mean, initially, it's just all mechanical. It's a dial you turn, and then they become more electronic. And now these things become more high tech. Okay, so well, essential features are like there's a real time clock, like I mentioned, but this could be a simpler version of real time clock. It needs to know day of the week, hour, minute, but many of the simpler ones don't know what day of the month or what year it is, okay, or what season. Just keeps repeating. But if you buy the more expensive ones, it might know, or it might have a sensor or the rain sensor to tell you, oh, it's raining, don't turn on the sprinkler. Now, there's also capability for doing scheduling, like the on-off time of the day, each zone, because there could be like 4, 6, 8, 10 zones. You turn on one at a time. There may be a feature for manual overriding because it's been dry and the landscape is dying, so you water it more, or it's been raining, you turn it off. Okay, so there's user interface for display input, electrical interface for on-off control. Of course, there's details at each level. As computer scientists may think in terms of just the digital part, but to make the whole system work, every part has to work. And in this case, like if we go back, right, the interface from the microcontroller to the valve usually would require voltage conversion, okay? Because the valve part, just to turn on and off, well, that might require something like 12 volts or higher, whereas your microcontroller probably runs at 3 volts. So then there needs to be a way to convert the signal voltage to one that can be accepted. So electrical issues, a lot of times computer scientists take it for granted, but when you design a system, you have to keep that in mind too. And so what's interesting about such an embedded system? Well, a lot of possible extensions, okay? And that's maybe something you want to think about for project ideas. Is you can take an existing system, rather than dreaming up a new system, you take an existing system and then try to make enhancements, add new features. What new features? Well, features that may already be built in to your microcontroller platform, such as the ability to network, connect to the internet, to network wirelessly, to sense different signals, to combine many other things, right? So one example is to add a rain sensor. And you can buy this as a product, actually. But it'd be nice to like add a rain sensor so it doesn't water. It's surprising that most of these sprinkler systems in use do not have a rain sensor. Okay, and so even if you add a rain sensor, how do you transmit the rain data, right? And actually you don't necessarily need a rain sensor, right? So you could use the weather service, right? So you could if your system has an ability to connect to the internet either directly or indirectly, directly meaning you hook it up to Ethernet and it logs into Yahoo Weather or something, or indirectly might be that you have a phone that can get online, and then every time you walk by, it gets an update, right? Something like that, right? And then you can obtain weather information without using your own sensor. There's trade-offs, right? And so you may be able to, do smarter watering this way. So with sensing or network connection, right? And another thing to add might be something that you might think is simple, but that's surprisingly lacking in many systems is battery backup. Because if the power ever goes out, then you could lose the time, you could lose lots of settings. So having a battery backup could be important. Another kind of possible embedded system is like a wireless ID card reader for taking attendance. So you might require somebody, instead of a signing sheet, which is kind of old tech, it might be good if somebody can just take out their ID and swipe it, and then that logs the data. Now, so there are these systems out there, but they're kind of expensive, and some are attached to like PDA or something. You may have seen something like that, and this was an older one that has like, this is called an HP. What is it called? iPac, and then of course there's iPhone versions or other tablet versions of this. You can swipe, but this tends to be a little more expensive, and if you have to pass a device like that around, there's a chance you might not get it back. Somebody might just say, "Hey, well, somebody just gave me a phone. Put it in your pocket." So then, better thing to do is to maybe build something that is not as expensive, and people might not want because they can't do much with it. Okay, so one possible way is to build two units. One is a gateway unit, and then you can hand out multiple of these scanners. And handheld units, they just need to connect to the gateway somehow. So if you scan or swipe a card, then it transmits wirelessly to this gateway unit, which then can either store things locally or connect to the internet and then store to a database. Right. So and you can have multiple of these units around, so that you can proceed simultaneously. Okay, so, and there could be many different ways. Some, you might use a phone that scans barcode. Others might use just these little swipe readers. It could be laser based, could be whichever. But they would all connect to some gateway unit, which then may be connected online, right? And so that way it gives you a lot of flexible options. So that's an example. And to make it happen, well, this goes into some of the details now, but you don't have to know the details for now. But before you choose or architect a system, you want to know, first identify what kind of peripherals might make sense to include. So it could be a card reader, could be wireless interface, could be LCD, could be something. And each one comes with an interface that it could be serial port, could be some interface, right? So some electrical interface. So when you choose a microcontroller or platform, then you need to figure out, well, does it have a way to connect and talk to this peripheral device? For most microcontrollers, the answer is going to be yes, but not always. And sometimes it's not just that whether or not it can talk to it, but whether or not it has enough resources, enough ports. Because, for example, you might have LCD, might have wireless, might have SD card, might have a few other things. And they might use the same kind of interface, but a particular microcontroller may have only one or two, but you need three devices. Is that going to work out? So in some cases, yes, because you can reuse or share some of the I/O resources, but other times, not always possible, right? So so when picking a microcontroller platform to use, that's part of the consideration. So you think from the functional point of view, then identify the possible peripherals and their connection requirements, and then you look at the microcontroller to see what features it provides, and then see if there's a way to at least assess whether it's possible to do the matching. So we will look at the interfaces for several weeks, and then you'll have a much better idea. So you can do an early assessment. Okay, and then of course there's a bunch of other devices